Hello student. In previous class, I discussed about the different method for the calculation of molecular mass. I clearly explained about the diffusion method. According to the Gram law of diffusion, this is the formula R1 by R2 is equal to root over of M2 by M1 is equal to V1 by V2 is equal to T2 by T1 is equal to root over of D2 by D1 is equal to root over of capital D2 by D1. By using this formula, you can find the molecular mass. Here is the some problems. Next, I discussed about the gram molecular volume method. As per the gram molecular volume method, the gram molecular volume of any gas occupy 22.4 liter at a STP. Here is the mathematical formula. Gram molecular mass is equal to W by V in ml at STP into 22,400. Next, you can also convert the ml into liter. You can also apply this formula in case of the volume where the volume is expressed in liter. So here you can also write another formula, that is your gram molecular GMM is equal to W by V in liter at STP into, that is your multiplication with 22.4. By applying this formula, I have done some problems in previous class. Next is the Victor Meyer's method. This method is applicable to the volatile substance. In this method, volatile substance is converted into vapor or gas. Then again same concept is applied, that is your gram molecular volume of any gas occupied 22.4 liter at STP. You can apply this formula and solve such type of problem. In this class, I will teach you about the another mass, that is your equivalent mass. Before going to the equivalent mass, I want to take a few examples regarding about the definition of equivalent mass. Suppose I will uh, take magnesium. Suppose I will take magnesium and want to reaction with the hydrogen. Then it gives magnesium hydride. Similarly, I will take magnesium plus oxygen gives magnesium oxide. I will take also magnesium plus chlorine gives magnesium chloride. Question is, suppose I want to find the equivalent mass of magnesium. Then how I will apply the concept? As per the equivalent mass can be detected by comparing with hydrogen, another is oxygen, another is chlorine. Why these three elements are used for comparison for the calculation of equivalent mass of any substance? Because generally we find generally we find the substance in hydride or oxide or chloride maximally found. All compounds are generally maximum related to the hydride, oxide, and chloride. That's why we compare with the hydrogen, oxygen, and chlorine for the calculation of the equivalent mass. Here is the question. Here is the question. When magnesium react with hydrogen, then it gives magnesium hydride. Question is, what amount of magnesium is used to react with the 1.008 8 gram of hydrogen? That amount of magnesium is considered as the equivalent mass of magnesium. Like that, you can also apply this concept. What amount of magnesium is used to react with the 8 part of oxygen? Similarly, you can also apply the chloride concept. What amount of magnesium is used to react with the 30.5 part of chlorine? So here you can say that the equivalent mass of a substance is the sum parts by mass of that substance, which can directly or indirectly combine or displace 1.008 part by mass of hydrogen, or 8 part by mass of oxygen, or 35.5 parts of chlorine. Here, the hydrogen, oxygen, or chlorine combined with or displaced. In some cases, what will happen? Hydrogen gas is released. For example, we can take Mg plus H2SO4 gives a MgSO4 plus hydrogen. What amount of hydrogen is released by taking what amount of magnesium? That is the concept. What amount of magnesium is taken for release of 1.008 gram of hydrogen? That is called the equivalent mass of magnesium. Similarly, you can also think about the release of chlorine, release of oxygen, whether hydrogen combine or displace, whether oxygen combine or displace, whether chlorine displace or combine. This is the concept. What amount of substance is needed to displace directly or indirectly, or that is your combine. You can also think about combine 1.008 part by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. So here you can think about the definition of equivalent mass is that the equivalent mass of substance is some parts by mass of that substance, which can directly or indirectly combine or displace 1.008 parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. This is equivalent mass. Remember, the equivalent mass is only a number. It does not have any unit. If the equivalent mass is expressed in gram, that is called gram equivalent mass. Like the gram molecular mass, like the gram atomic mass, there is also another term, that is your gram equivalent mass. When the equivalent mass is expressed in gram, that is called gram equivalent mass, or simply called gram equivalent. Here is a question. Take an example. Equivalent mass of magnesium is your 12. Suppose I want to find the gram equivalent mass of magnesium, then I can write here gram equivalent mass of magnesium is equal to 12 gram. Like think about the sodium. The equivalent mass of sodium is 23. Here there is no unit, because equivalent mass have no unit. Now find the gram equivalent mass of sodium. That is your 23 gram. Just write down the gm. That is your think about the gram. Then you will able to find the gram equivalent mass of any substance. Number of gram equivalent is equal to mass of element in gram divided by equivalent mass. What is the meaning of this sentence? Suppose we will think about the equivalent mass of H2SO4. H2SO4 having equivalent mass 49 gram. Here, suppose I will give 24.5 gram of H2SO4. Then I will tell what number of gram equivalent I will given you. Then you can find by using this formula what amount of H2SO4 is given to me. That is your 24.5. What is the gram equivalent mass of H2SO4? That is your 49 gram. Now I will find the number of gram equivalent is equal to what? 24.5 divided by 49 is equal to 0.5. Similarly, think about the another example. Here you can think that you will take another example. Suppose take sodium hydroxide. Suppose I have given you that is your 80 gram of sodium hydroxide. I want to say that how many number of gram equivalent I have given you. Then how will you able to find? At first, find the equivalent mass of sodium hydroxide. Here I can write the equivalent mass is your 23 plus 12 plus 23 plus 16 plus 1. That means here I can say that is your 40. 40, that is the aim, that is your atomic mass. By dividing the valency, you can find the equivalent mass 40. Here the equivalent mass is 40 and atomic mass is also 40. I will clearly explain about this how you will able to find the equivalent mass by using the atomic mass and valency. So here the question is what? How many number of gram equivalent of sodium hydroxide is given to me. So simply divide the total weight of sodium hydroxide, that is your 80 gram, divide by 40, that is the equivalent mass. So after calculation it is seen that that is your 2. So you can say that you can say that 80 gram of sodium hydroxide is equal to 2 gram equivalent. Similarly, you will take another examples and try to understand what is equivalent mass, what is gram equivalent mass, how can you detect the number of gram equivalent. An element that form more than one hydride, oxide or chloride will show a variable equivalent mass. Obviously, if an element form more hydride, more oxide, more type of chlorides, then obviously it have a different valency. If it have a different valency, then the equivalent mass must be changed. It have two or more equivalent mass. Think take an example. Suppose take an simple example first, that here oxide. You know that's Cu2O, Cu. Here, in case of Cu2O, the valence is your 1. In case of Cu, the valence is your 2. So, by using the formula, equivalent mass is equal to atomic mass by valency. Now, here the valence is different, but the atomic mass is that is your 63.5 constant. So here the since the valence is different, so there is different in the equivalent mass. That means here copper having in that means in copper oxide, copper having different equivalent mass. So it shows variable equivalent. Similarly, you can think about the hydrate. In case of H2S, valence of sulfur is your 2, equivalent mass of sulfur is your what? 32 by 2, that is your 16. But if you will think about H2S2, your valency of sulfur is 1, equivalent mass of sulfur is how much? 32 by 1, that is your 32. Like that, you can think about the chloride. In case of chloride, what will happen? Here I can think about one is the ferrous chloride, another is the ferric chloride. In ferrous chloride, the valency of iron is your 2, but in ferric chloride, the valency is your 3. So here look at that. In FeCl2, the equivalent mass is your 28. In FeCl3, the equivalent mass of iron is your 18.67. So here I can conclude that an element that form more than one hydride, an element that form more than one hydride, oxide or chloride will show a variable equivalent mass. Now move to the various method for determination of equivalent mass. At first, I used the general method. Equivalent mass of an element is equal to atomic mass divided by valency. By using the atomic mass and valency, you can able to find the equivalent mass of an element. Take an example. Equivalent mass of sodium is equal to 23 divided by 1 is equal to 23. Here 23 is the atomic mass and 1 is the valency. So equivalent mass is also having the value 23. Here both atomic mass and equivalent mass is the same. When the valence is 1, then the equivalent mass and atomic mass for an element is the same. Similarly, think about the magnesium. Look at that. Equivalent mass of magnesium is equal to 24 divided by 2, which is equal to 12. Here 24 is the atomic mass of magnesium, 2 is the valency. Like that, you can also find the equivalent mass of any element where the atomic mass and valency is given. Now think about the equivalent mass of a radical. This is the formula. Equivalent mass of a radical ion is equal to ionic mass divided by magnitude of charge. Here is an important point. How can you detect about the magnitude of charge? Suppose think about the sulfate SO4 2 minus. Here the charge is your 2, so the magnitude is your also 2. Similarly, think about the carbonate CO3 2 minus. Here the charge is your 2 minus, so the magnitude of charge is your 2. Similarly, you can think about NH4 plus. Charge is your 1, so the magnitude is your also 1. You can take any type of radicals and find the magnitude of charge first, then apply this formula. Ionic mass is nothing, it is atomic masses of the atom present in that in present in the ion. Look at that. If I will think about the ionic mass of sulfate, here the I can able to find by adding just the atomic mass of sulfur and 4 into atomic mass of oxygen. That means ionic mass is go how much? 1 into 1 into atomic mass of sulfur plus 4 into atomic mass of oxygen. That means here I can say that 32 plus 4 into 16. That is a 32 plus 64. That means here I can say that 96. Look at that. Here the magnitude of charge is your 2. Here the ionic mass is your 96. So equivalent mass of sulfate ion is equal to how much? 96 divided by 2, which is equal to 48. Similarly, you can find out the equivalent mass of carbonate. Here the ionic mass of carbonate 80 by 2 is equal to 30. Next formula is equivalent mass of an acid. Similarly, I will discuss about the equivalent mass of a base. For equivalent mass of an acid, we generally need the help of basicity. For equivalent mass of a base, we generally need the term acidity. At first, try to understand what is basicity and what is acidity. Basicity means number of replaceable H plus ion from one molecule of an acid. The number of H plus ion decides the basicity of the acids. Look at that. In HNO3, when HNO3 undergoes ionization, then one H plus and one NO3 minus ion is found. Here the number of H plus ion is your 1. So the basicity of HNO3 is 1. But if you will think about the H2SO4, here when H2SO4 undergoes dissociation, it gives it 2H plus. and SO4 2 minus ion. Since here the H plus ion is 2, the number of H plus ion is 2, so the basicity is here 2. Think about the H3PO3. Look at that. When H3PO3 undergoes dissociation, it gives you 2H plus HPO3 2 minus. Since here 2H plus uh, replaced, that's why the basicity of H3PO3 is your 2. No doubt here 3 hydrogen atom is present, but among the 3 hydrogen atom only 2 hydrogen is replaced. Here 3H plus ion is removed, so 63. So is equal to 63. That means the formula is equivalent mass of an acid is equal to molecular mass divided by basicity. And mass of a base is equal to molecular mass by acidity from one molecule of a base. If I'll think about different types of base, in case of sodium hydroxide, this is the ionization, that is your NOH, OH minus. Here one OH minus is removed, so here the acidity is your 1. But if you think about the calcium hydroxide, when calcium hydroxide undergoes dissociation, it gives Ca2 plus 2OH minus. So here the 2OH ion is removed. So here the acidity is your 2. But if you think about the aluminum hydroxide also gives 3OH ion. So here the acidity is your 3. Remember an important point. Suppose an acid having 3 hydrogen, then it is not surety. Then you cannot give a confirm that there are the 3 hydrogen, all the 3 hydrogen are removed, all the 3 hydrogen are displaced. Look at that. In H3PO3, there are 3 hydrogen atom is present, but only 2 hydrogen atom is displaced. You cannot say that here the basicity is 3, since here on the 2H plus ion is removed, so here the basicity is your 2. Now discuss about the equivalent mass of a base. Equivalent mass of a base is equal to molecular mass by acidity. Look at that. Equivalent mass of NOH. Here the molecular mass of NOH is 40 and the acidity of NOH is your 1. So here I can say that equivalent mass of NOH is equal to 40 by 1 is equal to 40. Similarly, equivalent mass of calcium hydroxide. Here the molecular mass of calcium hydroxide is your 74 and the acidity is your 2. So here I can say that equivalent mass of calcium hydroxide is equal to 74 divided by 2 is equal to 37. Next, move to the equivalent mass of a salt. Equivalent mass of a salt is equal to molecular mass divided by total positive charge or total negative charge. Look at that. Think about a salt, that is your MgCl2. In MgCl2, if you will think about the total positive charge, total negative charge, it can be find after when MgCl2 undergoes dissociation. When MgCl2 undergoes dissociation, it gives a Mg2 plus and 2Cl minus ion. Here the total positive charge is your 2, because 2 plus is present upon magnesium, which shows the total positive charge. If you will think about the total negative charge, look at that. Here the chloride ion is present and it carries the charge minus 1. Since 2 chlorine 2 chloride ion is present, so here I can say that the total negative charge is your minus 2. Here you can take the total negative charge or you can take the total positive charge, because in a salt the total positive charge must and total negative charge. Now move to the equivalent mass. So here I can write equivalent mass of MgCl2 is equal to 95 divided by 2, because here the total positive or negative charge is equal to 2 and the molecular mass is 95. So equivalent mass of MgCl2 is equal to 95 divided by 2, that is equal to 47.5. Like that, you can think about the sodium chloride. When sodium chloride undergoes dissociation, it gives Na plus Cl minus. Your total positive charge is equal to 1, total negative charge is equal to also 1. So here the equivalent mass of NaCl is equal to how much? 58.5 divided by 2. Here 58.5 is the molecular mass of sodium chloride. So here I can say that equivalent mass of sodium chloride is equal to 58.5 divided by 2 divided by 1, which is equal to 58.5. In this way you can able to find the equivalent mass of salt. In the upcoming class, I will discuss about the equivalent mass of a metal by using different method: oxide method, chloride method, hydrate method. There are number of methods for the calculation of equivalent mass of a metal. For this class, this is okay. Remember, an important point: you will download the notes of each class in the description. You go to the description. You will find a link and click the link. Then you can able to find the notes of each class. Thank you very much.